All right, today we're going to look at defining the derivative, and what we're going to specifically do is try to find the slope at a tangent. And I'm actually going to call this x right here. We're going to try and find the slope of the tangent right there in blue, okay, which we have not been able to do with pre-calculus up to this point. So let me use some other notation here. So this will be x f of x. Sorry about that. I need to update this. And then if I go up a distance h from here, I'm going to call this distance h. Some textbooks call that delta x. Okay, so then I'll be up here at x plus h amount. For example, if my x is 2, my h is 3, I go 2 up 3, I'd be at 5, right? X plus h would be 5. So I'm just going up h amount. So I'm going to name this point here x plus h is my input. So that's like my 5, right? I'm going from the 2 value of x plus h 3 amount, and I'm at 5. And then there's that y value f of x plus h, whatever it may be, right? And so if I find the slope between those 2 points, right? The slope between those 2 points, I'm going to come down here for a minute, would be y2 minus y1 over x2 minus x1. Well, if you notice, these x's cancel. And so my slope between those 2 points just ends up being f of x plus h minus f of x all over h. Okay? And that's the slope through those 2 points right there. Now remember, we want the slope of the tangent at x, right? So what I'm going to do is I'm going to bring h in. So I'm going to bring this in a little closer. So if I moved it to right here, now the slope is a little closer to my actual slope of the tangent in red, right? If I move h in. Well, if I move it in a little more, now my slope's a little closer, a little better estimation, right? So really I want to move it all the way in, if you will, right? In other words, I want to run the limit on that as that h distance goes to 0. And if I run the limit on that slope, if I run the limit as h goes to 0, as that distance h goes to 0, right? It's coming in, right? This point's coming in, down from here, down, down, and finally I end up with my slope of the tangent when I run the limit on that. That's called a limiting process. It's a limiting process, and that is the derivative. The derivative is the limit as h goes to 0 of f of x plus h minus f of x all over x plus h minus x, and of course our x's cancel. Right? So limit as h goes to 0 of the slope. And that's what we're going to use to find the derivative, the slope of the tangent equation. And we could find the equation of the tangent line as well after we found the slope, right? Because then we'll have a slope and we'll have a point. So let's go ahead and do that on this first one. Let me erase some of that. And so slope of the tangent, f prime of x, derivative of x, is limit h goes to 0, f of x plus h, minus f of x, all over x plus h minus x. Again, the x's cancel on that, so I'm just left with h down there. All right, so we've got this 5 minus x squared, and we're trying to find, let me give you a picture of this. Okay, here's 5 minus x squared. Can't draw that okay. We're trying to find the equation of the tangent line right here at 2, 1. So we're trying to find, first of all, we've got to find the slope. So if you notice, this slope here will be negative. All right, I'll have a negative slope. And then I'm going to, once I use that, so I'm going to plug it into the slope of the tangent line that I have here, limit as h goes to 0, all that stuff. Once I have that slope, then I'm going to use the point and write the equation of that red line. Okay. So let's go through the process. So f prime of x, or the slope of the tangent, is limit h goes to 0 of f of x plus h. Well, here's f of x, negative x squared plus 5. So f of x plus h would just plug in x plus h. Right? So negative x plus h squared plus 5. Minus, and now we're subtracting the original f of x. Well, the original f of x is 5 minus x squared, or negative x squared plus 5. Same thing. So there's, in blue, again in blue, I have f of x plus h minus f of x, and it's all over just an h. Okay, this is called the difference quotient. We're trying to simplify this difference quotient, if you remember finding the difference quotient in your pre-calc class. So limit h goes to 0. Now I'm going to expand this. X plus h plus 5. I'm going to distribute that. So plus x squared minus 5 is all over h. So I have x squared plus xh plus hx, so two of these xh's, plus h squared plus 5 plus x squared minus 5 is all over h. Now I'm going to distribute the negative through. So I have negative x squared minus 2xh minus h squared plus 5 plus x squared minus 5 all over h. Notice my 5's are gone. Notice my x squareds are gone. And I'm left with limit h goes to 0 of negative 2xh minus h squared all over h. Now I can't plug 0 in for h because I get a 0 on the bottom, right? So what I'm trying to do with this difference quotient is I'm trying to simplify this down and take an h out of each term so it'll cancel out with the bottom. So this becomes an h I'm going to take out. I have negative 2x minus an h all over h. And see how those h's cancel? And now I can throw it in. So now I have negative 2x minus, remember h is 0. H is going to 0, so minus 0. So I have negative 2x. Okay? Kind of running out of room here. So f prime of x, in other words, the slope of the tangent is negative 2x. I'm going to have to erase some of this stuff here. Okay, so the slope of the tangent, f prime of x, is negative 2x is what we found, right? So that's the slope of the tangent. Well, the question is where at? We're finding the slope at what point? What's the point we're looking at? Remember, this was the point 2, 1, right? So I'm finding the slope of the tangent at 2, 1. So my x value is 2. So I plug it in. Negative 4. So the slope of the tangent at negative 2 is negative 4. That red line has a slope of negative 4. So now I say, oh, I know my slope is negative 4. And I know it only goes through the point 2, 1. Oops, 2, 1. So I can write the equation now. Y minus y1, which is 1, equals m, negative 4, x minus x1, which is 2. Add 1 to both sides. That's the equation of the tangent line to the graph of negative x squared plus 5 at that point. That's the equation of that red linear line. Okay, so the slope of the tangent. So I had to use that difference quotient to get to that point, right? So this next one here. Now we've got find the equation of the tangent line at the point negative 1, negative 9. So this is t cubed minus 8. See if I can draw this best I can. Oh, it's terrible. But anyways, at this negative 1, negative 9, I'm trying to find the slope first. I'm going to find the slope of that tangent line, and then I'm going to write the equation of that red line. All right? So number one, I'm going to say, well, slope of the tangent, which we call the derivative at x, is the limit as h goes to 0 of f of x plus h minus f of x, y2 minus y1, over x2 minus x1. Again, the x's cancel. There's our difference quotient. So we have limit f of x plus h. So I have t plus h cubed minus 8. There's f of x plus h, but I'm using t's here, minus the original function. Now the original function is t cubed minus 8, that parentheses, minus the original function. And this is all over h, right? So t plus h, t plus h, t plus h, minus t cubed plus 8, it's all over h. We do these first ones. So t squared plus 2 of these th's or ht's plus h squared. Still got another t plus h. I'm going to take the t through to each of those. I'm going to take the h through to each of those. I have a minus 8 minus t cubed plus 8. Now, notice a t cubed minus a t cubed, that's gone. I got a minus 8 plus 8, that's gone. Let's see, anything else? 2t squared h plus another t squared h, so that's 3 of those t squared h's. And then I have th squared plus 2th squared is 3th squared. And then it looks like I have a h cubed on the end here. And this is all over h on the bottom. Now remember, I'm trying to get a factor in h out, this top here. So take an h out, and I have 3t squared plus 3t. Now there's only one h left, and h squared. It's all over h, so that those h's cancel. And now let's throw 0 in for h. So I got 3t squared plus 3t0 plus 0 squared. So that's gone, that's gone. I'm just left with 3t squared on this. Okay? So that's, let me go over here. So f prime, and I'm using x's. So the slope of the tangent is, I'm using t's, is f prime of t instead of x, is 3t squared. Now remember, we wanted the slope at that point, what was it, -1, -9. -1, -9. So let's plug in -1. So -1 squared 1, 3 times 1, 3. So my slope, the tangent at -1, -9 is 3. My slope is 3. So that red line up here I drew, this slope is 3. All right, so now I know, so I know f prime of -1 is 3. Again, that's my slope at -1, -9. So y minus y1 equals m, x minus x1, y minus the -9 equals 3, x minus -1. Subtract 9, and we've got 3x minus 6. All right, let's take a look at this next one. I'll try and give you a visual again. Here's, 8 over x squared. Let me see if I can get kind of like this. You got the vertical asymptote, x equals 0. Got a horizontal asymptote, x equals 0. We're trying to find that right there. I don't know how, I didn't draw that the greatest, but anyways, we're trying to find that red equation of that tangent line right there at 2, 2, right? So we got to find the slope there first using our difference quotient with a limiting process there, and then we'll use that 0.22. So let's go ahead and start with our f prime of x, which is the slope of the tangent. Limit as h goes to 0, f of x plus h minus f of x all over x plus h minus x. Again, the x's are gone. So we've got limit h goes to 0, f of x plus h. So we got 8 over x plus h squared minus the original function, which is 8 over x squared. This is all over h. Now, before I expand that x plus h squared, let's go ahead and get a common denominator here. So I got to give this an x plus h squared. I got to give this one over here on the left, give it an x squared. Okay, and so we've got limit h goes to 0 of 8x squared minus 8x plus h squared. This is all over this common denominator. And then this is all over h. Well, if it's over h over 1, I'm just going to multiply by 1 over h. 1 over h. Right? And so we'll just have that limit h goes to 0 of 8x squared minus 8x plus h all over h x squared x plus h squared. And let's go ahead and keep going. So notice those are gone. I want to take an h out of the top, out of each of those, so negative 16x minus 8, so that it cancels with that h on the bottom. So that h and that h cancels. Remember, we're taking the limit as h goes to 0. And now we can throw that 0 in for h fine. 16x minus 8 over x squared times x plus 0 squared. So we got negative 16x minus 8 over x squared times another x squared, which is x to the 4th. Right? And so this is f prime at x. Now remember, we wanted this at, hold on, just checking my work here. Yeah, I wanted this at 2, 2, right? 2, 2. So 2 is my x value. I want the slope of the tangent at 2, 2. So my x is 2. So f prime at 2, negative 16 times 2 minus 8 over 2 to the 4th. So I got negative 32 minus 8 over 2 to the 4th is 16. So I got negative 40 over 16. Guys, I'm so sorry. I totally jacked this up. I had a stinking error right here. That should be an h squared. Oh, I'm so sorry. So I take negative 16h. I take an h out, and I still have an h there. So I have an h there, which means I have a 0 there.
Thing froze up and
yeah, so I have a 0 here, right? So that's got to be a 0 right there. Sorry about that. Oh, made a mess of this. So that's a negative 32 over 16, which is negative 2. I knew I had an integer for my slope, so I knew I'd screwed that stupid thing up. But anyways, our slope of the tangent, f prime at 2, is -2. So the slope of the red up here, this slope is -2, and it's at 2, 2. So can we write the equation at this point? You bet we can. Y minus y1 equals our slope, -2, which, boy, I messed that up. Sorry about that, you guys. And add 2. There we go. That's the equation of that. Thanks for your patience on that one. All right, this next one here, we've got square root of x plus 1. Looks a lot like square root of x, except it's moved to the left one. And I should have that go through 3. Oh gosh. So we're trying to find slope of that tangent right through there, right? So we'll have a positive slope here. Not sure what it is. It looks like it's less than 1 though. And then use that point to write the equation of that red line again. So let's go ahead and go through finding the slope of the tangent, which is the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. So f prime of x, f of x plus h. So now we have square root of x plus h plus 1 minus the original function, square root of x plus h. This is all over h. Yeah, so you got here's our square root of x plus 1. So if I plug in x plus h here, just to show you guys this, x plus h is going in for that x. Makes sense? Yeah, and I'm subtracting the original function. This was pointed out, sorry about that. My original function is not square root of x plus h. It is x plus 1. So the original function, there we go. All right. Now remember, we're trying to get rid of the h, right? We can't plug an h in because it'll give us a 0 on the bottom here. So we got to get a little creative with this, and we're just going to have to multiply by the conjugate. That's the only way we can kind of manipulate this. So we're going to multiply by square root of x plus h plus 1 plus conjugate, meaning we're switching the inside there, or the sign between them, changing that from a minus to a plus in this case. But if I do it to the top, I got to do it to the bottom. Okay, and then, again, this is being multiplied. So now let's go ahead and FOIL this. And so you'll have limit as h goes to 0. X plus h, square root of x plus h plus 1 times square root of x plus h plus 1 will undo that. And then you have plus a square root of x plus 1, square root of x plus h plus 1, but then you have a minus square root of x plus 1, square root of x plus h plus 1. And those are like terms, so those are just going to cancel. And then your last ones, negative root x plus 1 times root x plus 1 is just an x plus 1. It undoes that radical. And this is all over h square root of x plus h plus 1 plus square root of x plus 1. And I'm going to go ahead and distribute that minus through as well. So I got x plus h plus 1 minus x minus 1 limit as h goes to 0. Now notice x minus x, gone. 1 minus 1, gone. So all I'm left with is an h on top, h on the bottom. I wanted that to cancel. It does cancel, so I'm just left with a 1 on top. So 1 over square root of x plus h plus 1 plus square root of x plus 1. This is the limit as h goes to 0. Now I can throw my 0 in. So x plus 0 plus 1 plus square root of x plus 1. So I get 1 over square root of x plus 1 plus another square root of x plus 1 is 2 of these square root of x plus 1s. And that is my derivative, f prime of x. Now remember, we wanted this at the point 8, 3. At 8, 3. So I'm plugging 8 in for x. So I got 1 over 2 square root of 8 plus 1. Well, square root of 9 is 3. So I got 2 times 3 on the bottom, which is 6. So my slope of the tangent is 1/6. So now I know, let me come back up here. So I have the slope is 1/6. I wanted to do it at the point 8, 3. If you remember our little picture up here, right there. All right, f prime at 8, or slope of the tangent is 1/6. So y minus y1 equals slope x minus 8 minus 8/6, or 4/3. Now I add 3, or 9/3. So I have 1/6 x plus 5/3. And there's the slope of that. I'm sorry, the equation of the tangent line, which includes the slope of the tangent there, right? Through that point 8, 3. All right, so we've got some quadratic here. You know, I don't know where it's at, but I'm just looking for, where's this thing have a horizontal tangent? Well, if I have a horizontal tangent, what's its slope? 0. So I have to have a slope of 0. Slope of the tangent is 0. Well, it's not here. That slope would be positive, right? It's not that one. Where would it be on a parabola? At the vertex, exactly. So I'm looking for, I'm like, hey, what's that point? Where is my slope? 0. Well, it's pretty easy for parabola, but it's not so easy when you get like cubics or fifth power polynomials and so on. You got to do the calculus. So we'll do the calculus with kind of a more basic quadratic here and show you how to do that. So the slope of the tangent, which is f prime of x, let's go through it. This has to be 0, right? This will end up being 0. So we're going to just work the right-hand side down to our difference, our derivative function, and then set that equal to 0 and solve for x. And then we'll know at what x value I have a slope of 0. Slope of the tangent 0. So 3x plus h squared minus 6x plus h plus 1 minus the original function, which is just 3x squared minus 6x plus 1. This is all over h. And again, we're trying to set this, where is the slope 0? That's why I got a 0 equals on the left-hand side there. 3x squared plus 2xh plus h squared minus 6x minus 6h plus 1 minus 3x squared plus 6x minus 1. This is all over h. 3x squared plus 6xh plus 3h squared. All right, 3x squared minus 6 squared. Looks like that's gone. I got a plus 1. I got a minus 1. It looks like that's gone. I got a minus 6x. I got a plus 6x. That's gone. So I have 6xh. I'm going to take an x out. 3h squared. I'm going to take an h out. And I have minus 6h. I'm going to take an h out. Now I'm going to throw the 0 in for h. So I have 6x plus 3 times 0 minus 6. So I'm just left with 6x minus 6. There's my derivative. There's my slope of the tangent. Well, we said the slope of the tangent's got to be horizontal, right? Up here we said, at what point does it have a horizontal tangent? In other words, where's my slope? 0. And now we're going to solve for x. So we'll add 6 to both sides, divide by 6. So it happens when x is 1. Well, at what point is that? Well, I'm not sure because I don't know what my y value is yet. So here's my original function. Let's find where that vertex is in this case. 3 times 1 squared minus 6 times 1 plus 1. I got 3 minus 6, negative 3 plus 1 is negative 2. So you have horizontal tangent at 1, negative 2 when x is 1. Let's go back up here and look at it. So this is 1. I drew this pretty good actually. 1, negative 2 is where that is. 1, negative 2. Thanks so much for watching. See you next time.